Mr. Trutna here. We're going to go over vertex form of quadratic equations. There's going to be 7 problems that we're going to do, and the 7 problems are going to coincide with the problems that you were assigned to. Okay. So what we're going to do is we're going to find the vertex of this vertex form of the equation. So remember, to find the vertex, this vertex form is very simple, or very user-friendly for the vertex. So the x-coordinate of the vertex is going to be 2. It's always the number inside the parentheses immediately after the subtraction symbol. Then the y-coordinate of the vertex is always going to be the number outside the parentheses, but remember, in vertex form we want it to be an addition symbol out here. So instead of -4, we have to think of this as plus -4. So that means that the y-coordinate of my vertex is 2, -4. Okay, now once I have my vertex, I'm going to make a table. My table is going to have 3 values in it. And remember, the middle value for your table is always going to be your vertex, which is going to be the coordinates 2, -4. Then you're going to pick an x value, one above the vertex is x, which would be 3, and one below, which would be 1. Okay, and then what we do is we look at the a value of my vertex form. So if you notice, my a value of my vertex form is -3. So a is equal to -3. So that a value tells me that for each one of my y values, I should go down 3. Okay, so this is going to be -7 and -7, down 3 from the vertex. Now, what I do is I use those points in order for me to make a sketch or a graph of what my parabola is going to look like. Okay, I'm just going to plot these 3 points, and I'm going to get an idea of what my parabola looks like. So I'm going to plot the point +3, -7, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. I'm going to plot the point +2, -4. So that's over 2, down 4. And then I'm going to plot the point 1, -7, which is right here. And then what we do is we connect the dots with a nice smooth U, because remember, a parabola is a U-shaped graph. Extend the dots, extend the parabola a little bit past those points right there. So that would be the graph for number 1. Okay, then there were 2 other things that I asked you to identify. So the 2 other things that I asked you to identify were the domain of the graph and the range of the graph. Okay, so what's the domain of a parabola? Remember, the domain is always all real numbers. So my domain is going to be all real numbers. Okay, and then the range is how far the graph goes down, and since this graph goes down continuously, that would be -infinity to how high the graph goes up. Well, the graph stops going up right here, which is at -4. So we would say the range is -infinity to -4, and the way that we can write that as an inequality, remember, range coincides with the y value, so this is all numbers less than or equal to -4. So y is less than or equal to -4. That'd be number 1. Number 2, the equation was y is equal to quantity x plus 2 squared, then -1. Okay, so what's my a value? So my a value is going to be 1. All right, my h value is going to be the number inside the parentheses after the subtraction sign. So I have to rewrite the parentheses as -2 squared. So that means my h value is going to be -2, and then my k value is the number outside the parentheses after the addition sign. So I have to rewrite -1 as plus -1. So that makes my k value -1. Okay, so that gives me my vertex. So remember, my vertex is always my h value, -2, and then my k value, -1. Now, from that, I can generate, knowing my a value is 1, I can generate a table with 3 values, so I can get an idea of what my parabola is going to look like. Okay, so I take my vertex and I put it in the middle of my table, just like that. Okay, then I pick an x value 1 space above -2, which would be -1, and 1 space below, which would be -3. Then I go to my a value. My a value is positive 1. So that means for both of these y's here, I'm going to go up by 1. So negative 1 plus 1 is 0, and this one's going to be 0 as well. Okay, I use that information to make a graph of what my parabola is. So I draw my x-axis, I draw my y-axis, just like I've done right here, and then I'm going to plot these 3 points. So negative 1, 0 is right there. Negative 2, negative 1 is that point right there. Negative 3, 0 is that point right there. And then we connect the dots with a nice smooth U-shaped graph, and that gives us an idea of what my parabola is going to look like. Okay, so now the last 2 things are, what is the domain of this graph? Well, the domain is all real numbers. And remember, that's the symbol, that weird looking R is the symbol for all real numbers, okay? And then what is my range? Well, my range is how far my graph goes down. So you can see my graph goes down -1 spots. 2, how high does it go up? And this graph keeps going up, so it goes to infinity. If I wanted to write that as an inequality, I would write y is greater than or equal to -1, all numbers greater than or equal to -1. So that would be how we did number 2. Number 3, the equation was f of x, so we have the function of x is equal to -2 quantity x minus 5 to the second power plus 2. Okay, so the first thing I'm going to do is I'm going to identify my a value. My a value is -2. My h value is going to be -5. My k value is going to be +2. Okay, now since I know that, I now know where the coordinates of my vertex are. My vertex's coordinates are always h then k. So coordinates of -5, +2. Then I use those coordinates to generate a table. And my table is going to have 3 values in it. Okay, the middle value, I put my vertex, -5, +2. Then I go 1 for my x value. I pick 1 space above -5, which would be -4, and 1 space below -2. Then my a value tells me how much I should go up or down for my y vertex. My a is -2, so that's telling me I need to go down 2, 2 minus 2, so both of these y values are 0. Then I use this table and I treat these as 3 points, and I make a sketch of my graph of what my parabola is going to look like. Alright, so I plot the point -4, 0. There's the point -4, 0. I plot the point -5, +2. And then I plot the point -6, 0. And then I connect the 3 points in a nice smooth U. Don't make it a V, totally different graph, totally different equation. I extend the arrows going down. Okay, so then the last thing is, or the last 2 things is, what is my domain? Well, remember, the domain of all parabolas is all real numbers. Then what is the range? Well, the range is how far my graph goes down. It keeps going down continuously, so that would be -infinity. 2, how high does my parabola go up? It goes up to +2. Alright, so what this is saying is my range is any number 2 or smaller. And the way I would write that is y is less than or equal to 2. The range is always your y values. Okay, so that's how we would do number 3. Moving on, number 4, the equation that you were given for number 4 was the function f, or f of x, is equal to 4, then quantity x minus 3, close the quantity, squared, minus 6. Alright, so what is my a value? My a value is going to be 4. What is my h value? My h value is going to be +3. What is my k value? Now remember, your k value is always the number outside the parentheses after the addition symbol. So you have to think of -6 as plus -6. So your k value is going to be -6. Okay, so then once I know my h and my k, I could now identify my vertex coordinates. So my vertex coordinates are going to be 3, -6. I can now use that vertex and use my a value to generate a table that's going to help me make my graph of my parabola. I put the vertex coordinates right in the middle of my table. So I put 3, -6 in the middle. Then I pick one x value above 3. 1 above 3 is 4. 1 below 3 is 2. Okay? Then to fill out my y values for my table, I look at my a value. My a value is +4. So this means both of these y values should go up 4 from -6. So that would put both of the y values at -2. Okay? And then I use this table to generate a graph of what my parabola is going to look like. So I make a quick sketch of my coordinate grid here, and then I plot these 3 points. So I go over 4 down 2, that'd be 4 where 4 -2 is. I go over 3 down 6, 2, 3, 4, 5, 6. That's where 3 -6 is, and then I go over 2 down 2. And then what I do is I connect my 3 points with a nice smooth U, and then I extend my parabola a little bit past those points. There's gives me an idea of what my parabola looks like. Okay, so what's the domain of that graph? Well, the domain is how wide does the graph get? Well, parabolas just continuously keep getting wider and wider and wider, so my domain is all real numbers. All right, what is the range of my graph? Well, my range is how far does my graph go down? So my graph goes down right there, and that's -6. 2, how high does my graph go up? It keeps going up continuously to infinity. So this means my range is negative, any number, -6 or greater. And the way I write that is y is greater than or equal to -6. All right, number 5, 3 more to go. So in number 5, the equation that you were given was y is equal to -2, quantity x minus 2, close the quantity to the second power plus 1. All right, so this is in vertex form. So what's my a value? It's -2. What's my h value? My h value is right there. It's 2. What's my k value? My k value is the number after the addition sign, which is +1. Since I know that, I now know where my vertex coordinates are. 2, 1. H and k tell me where my vertex is. So my vertex's coordinates are the point 2, 1. Okay? Now, from that, since I know my vertex, I can now generate a table that's going to help me get a graph of my parabola. I put my vertex right in the middle of my table. I'm only going to pick 3 values, so I pick 1 value above 2, 1 value below table, which 2, which would be 3 and 1 in my table, and then I take a look at my a value. So since my a value is -2, that tells me my y values have to go down 2. So 1 down 2 takes me to -1. So each of those would go to -1. And then I treat those values as 3 points, and I plot the 3 points on a graph. So when I do that, on my graph here, I plot the point over 3 down 1. I plot the point over 2 up 1. I plot the point over 1 down 1. And then I connect the 3 dots in a nice smooth U, and that gives me an idea of what my parabola looks like. Okay? Once I have my parabola, I can now identify my domain and my range. You really should be able to identify both of them even without a graph, but a graph helps. So what's my domain? Does my graph keep getting wider and wider and wider to the left and the right? Absolutely it does. So my domain is all real numbers. What's my range? Does my graph keep going down forever? Yes, it does. So it's -infinity. 2, does my graph go up forever? No, it stops going up at +1. So my range is -infinity to 1. So what we're saying is your range is any number 1 or smaller, and the way we would write that is y is less than or equal to 1. All right? Number 6. Second to last problem that you were assigned from the vertex form of a parabola. So number 6 is y is equal to 3 times the quantity just means parentheses, x minus 4 to the second power minus 7. All right, so this is in vertex form once again. How do I know it's in vertex form? Well, we have the parentheses to the second power. So what's your a value? Well, your a value is 3. What's your h value? Your h value is positive 4. Your h value is always the number inside the parentheses after the subtraction sign. What's your k value? Your k value is the number outside the parentheses, but it's after the addition sign. So you have to think of minus 7 as plus negative 7. So k is going to be negative 7. So a is 3, h is 4, k is negative 7. That means that my vertex has coordinates at h, 4, comma, k, negative 7. Once I have my vertex, I can now use my vertex to generate a 3-point table. So that'll then give me an idea of what my parabola is going to look like. I put my vertex's point in the middle of my table. I pick one value above the vertex's x, 5, one below, which is 3. Then I look at my a value. My a value tells me to go up or down for my y values. My a value is positive 3. So that means I'm going to go up 3, which would take me to negative 4 for both of these y values. All right, and then I use these 3 values as 3 points, and those 3 points help me generate what my parabola is going to look like. So I plot these 3 points. Over 5, 3, 4, 5, down 4. Over 4, down negative 7. Over 3, down negative 4. So you could see that I get a general sense of what my parabola looks like. So I connect the 3 points with a nice smooth U. Once again, don't make it a V. Make it a U. Parabolas are in a U shape. Extend the parabola past the points. Okay, and now we're going to denote what is the domain and what is the range. Well, the domain for every parabola is all numbers, so it's all real numbers. And then the range is going to be, how far does my parabola go down? Well, it stops going down right there, which is at negative 7. To how high does my parabola go up? My parabola goes up continuously. So my range would be negative 7 to infinity. That means it's negative 7 or any number greater than that. And the way I write that is y is greater than or equal to negative 7. There's my range. Okay, last problem, number 7. So number 7 was y equals 1/2 quantity x plus 1 squared plus 5. Okay, so number 7 is in vertex form. So the a value is going to be 1/2. The h value is going to be the number inside the parentheses after the subtraction symbol. So we have to think of plus 1 as minus 1. So my h value is negative 1. And then my k value is the number after the addition sign outside to the right of the parentheses, 5. Okay, so what does that mean? Well, it means that my vertex, I now know the coordinates of my vertex. It is negative 1, positive 5. And I could now use my vertex to generate a 3-point table, which I will use to get an idea of what my parabola looks like. Put the vertex in the middle of your table, pick one value, one space above the vertex for x, which would be 0, one below, which is negative 2. Then, for my a value, what I do is my a value is 1/2. So that means both of my y values are going to go up by 1/2. Okay, 5 plus 1/2 gives me 5.5. So both of these y values will be at 5.5. I use this table to generate 3 points in order to get an idea of what my parabola is going to look like. Okay, so I plot the points. Over 0, up 5.5 spots. 1, 2, 3, 4, 5.5. I put a point. Then I go over to -1 and I go up 5 spots. Then I go over to -2 and I go up 5.5 spots. And you can see if when I connect my 3 points together in a nice smooth U, I get a little bit wider than normal parabola, and that's what I would expect, because remember, when your A value is when the absolute value of your A is anywhere between 0 and 1, you get a wider than normal parabola. Okay, so last, what is my domain? Well, my domain is all real numbers. Why is it all real numbers? Because my parabola keeps getting wider and wider and wider, to the left and to the right. What is my range? How far does this graph go down? Well, it goes down. It stops right there, which is at +5. So it goes down to 5 to, how high does it go up? Well, it keeps going up continuously, so my range is +5 to infinity. So that means my range is 5 or anything greater than equal to 5. The way I write that is y is greater than or equal to 5. Okay, hopefully this video helped. If you have questions, please come to class and ask away. And we'll see you next time.